Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve this interesting summation. We have to prove sum of 0 to n choose k times minus 1 to the k over 2k plus 1, and the answer is 2n double factorial over 2n plus 1 double factorial. Well, how to begin? Okay, first let's consider left hand side. So left hand side is equal to here k is equal 0 to n choose k, and here minus 1 to the k power, and we have 1 over 2k plus 1. So if we integrate x to the 2k from 0 to 1, we know using general power rule we have x to the 2k plus 1 over 2k plus 1 from 0 to 1, and if we apply limit we have 1 over 2k plus 1. Therefore instead of 1 over 2k plus 1 we can use this integral from 0 to 1 x to the 2k times dx. Okay, then we can switch the sigma notation and integral sign. So we have integral from 0 to 1 sum of k is equal 0 to n choose k times minus 1 to the k power times x to the 2k times dx. Okay, then we can simplify integral from 0 to 1. Here sum of k is equal 0 to n choose k. Now minus 1 to the k times x to the 2k, we can write minus x square raised to the k power dx. Okay, now this is an interesting thing. This part we know the binomial expansion of 1 plus x to the n is equal to sum of k is equal 0 to n choose k times x to the k. Now instead of x, if we use 1 minus x square, instead of x minus x square, so 1 minus x square raised to the n is equal to sum of 0 to n choose k times minus x square raised to the k power. So now we have this part and this part, we know same, so we can write this is equal to integral from 0 to 1 minus x square raised to the n power times dx. Okay, then we have to evaluate an interesting integral. To solve this integral we can take a substitution, so we can take x square is equal to u, then if we differentiate 2 times x dx is equal to du, so we can plug in limit, we know also 0 to 1 minus x square, we know u, so u to the here n, and dx we know du over 2 times x we can isolate the x, u to the 1 half. Okay, then 1 over 2 we know constant, so we can write outside of the integral sign 1 over 2 integral from 0 to 1. Now variable u, so we can change the variable because definite integral independent of the variable, therefore we can write 1 minus x to the n times x to the minus 1 half dx. Okay, then we know about beta function. Beta of ab is equal to integral from 0 to 1 x to the a minus 1 times 1 minus x to the b minus 1 times dx. Well, now here x to the a minus 1, here x to the minus 1 half, so a minus 1 is equal to minus 1 half, therefore a is equal to 1 minus 1 half, so we have 1 half. Then here in here b minus 1, So b minus 1 is equal to n and b is equal to 1 plus n. Therefore, we can write our integral is equal to 1 half beta of 1 half comma 1 plus n. Okay, then we know the relation between gamma function and beta function. Beta of mn is equal to gamma of m gamma of n over gamma of m plus n. So we can plug in here 1 half gamma of 1 half times gamma of n plus 1 over gamma of 1 half plus n plus 1. Okay, then 1 half gamma of 1 half we know the square root of pi, and gamma of n plus we know n factorial over here we have in the denominator gamma of 1 half plus n plus 1. We know gamma of n plus 1 is equal to n times gamma of n. So here we have a gamma of 1 plus n plus 1 half. So we can write here n plus 1 half times gamma of n plus 1 half. Okay, then now we have the square root of pi over 2 n factorial over here n plus 1 half n plus 1 half, and now we have gamma of n plus 1 half. In a previous video we proved this identity. Gamma of n plus 1 half is equal to square root of pi over 2 to the n times 2n minus 1 double factorial. If you like to watch that video about double factorial, I will add the link in the description and also make a card. Anyway, now instead of gamma of n plus 1 half, we have the square root of pi over 2 to the n. So 2 to the n times here 2n minus 1 double factorial. Well, now we have to simplify. So here the square root of pi, the square root of pi we know get cancelled, and also in double factorial video we discuss about this formula. 2n double factorial is equal to n factorial times 2 to the n. So in the numerator we have 2n double factorial over here now n plus 1 half. So if we take the common denominator, we know this 2 and this 2 get cancelled. So we have 2n plus 1 times 2n minus 1 double factorial. Okay, now 2n double factorial over now 2n plus 1 times 2n minus 1 double factorial. We know this is equal to 2n plus 1 double factorial. Okay, we are done. This is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.